Some properties of the M-class star is that they are the coolest, dimmest, tiniest, most common stars, have long lifespan, and appear red. Every star begins with a cloud of gas and dust called nebula. The matter collects due to gravity, pushing increasingly inward, creating a protostar. Then, the star gravity and pressure increase, forcing the protostar to collapse down, then creating another T-Tauri star. The temperature gets so hot, and nuclear fusion eventually begins establishing an equilibrium star called a red dwarf. Red dwarf star is convective, meaning that the helium and hydrogen constantly mix, so it burns so slowly over a trillion years. And then, when the hydrogen supply and the core is exhausted, fusion stops, and the star no longer generates an outward pressure to counteract the inward pressure pulling it together. The core of the star will shrink and get hotter, which makes the remaining hydrogen burn even faster. Ionized helium surrounds a shell of hydrogen. Fusion causes the outer atmosphere to increase in size dramatically. As the outer layer expands, they cool and thus become more and more red. Then, it becomes a red giant star and can be 100 times larger than the red dwarf star before. Stars typically spend just 1% of their life in the red giant phase. The example of the red giant star is Aldebaran and Mira. More massive M-class stars evolve more quickly and further increase in size to become a red supergiant. Example of the red supergiant is Betelgeuse. The red giant phase will only last a few 100 million years before it runs out of fuel completely.
Next is the death of M Spectral class star. M class star was a red supergiant. The range of estimate is 20,000 to maximum of 140,000 years. M class star is a runaway star that is traveling quickly across space and appears to experience brief episodes of significant mass loss. It has been a red supergiant for at least a few thousand years, as the earliest dredge up only happened when a star entered the red supergiant phase. For spinning star and model with extremely high mass loss rate, more massive stars can lose mass quickly enough to evolve toward higher temperature before their core can collapse. This star can generate type 2L, type 2b or type 1b overseas supernovae from yellow or blue supergiant or Wood Riot star. M-class star will explode when the projected beginning circumstances and estimate amount of time it has been a red supergiant are met. M-class star as a 2p supernova would have a peak apparent magnitude somewhere in the range -8 to -12. This will be easily visible in daylight with a possible brightness up to a significant fraction of the full moon truly light not exceeding it. This type of supernova will remain at roughly constant brightness for 2 to 3 months before rapidly dimming. M-class star has been the focus of numerous rumors and scare stories claiming that it will explode within a year, giving rise to inflated claims about the effect of such catastrophe. Following the eventual supernova, a small dense remnant will be left behind, either a neutron star or black hole. M-class star does not have a core massive enough for a black hole, so that remnant is predicted to be neutron star of approximately 1.5 solar mass. Next is example of M spectral class. First one is VY Canis majoris. VY Canis majoris is a red hypergiant. The size between 1,800 and 2,100 times the size of the Sun, but only up about 30 to 40 times its mass. As it nearly 5,000 light years away, it is difficult to be more exact. If it were replaced to the Sun, it would reach beyond the orbit of Jupiter, almost to Saturn. Earth would certainly be engulfed. VY Canis majoris ejects huge amount of gas during its outburst. The star does not have much longer to live and will explode in a supernova. Next is Barnard star. Barnard star has the largest proper motion of any known star, which is 10.39 seconds of arc annually. It is a red dwarf star. Barnard star is gradually coming nearer the solar system, and by the year 11,800 will reach its closest point in distance. two planetary partners with orbital period of 30.5 and 19 years respectively, and masses around two-thirds that of Jupiter were thought to be the source of this perturbation. The last one is Mira. Mira is a red supergiant star that was estimated in the past to be about 220 light years away. Oscillating variable star of the Mira variable star, for which it is the prototype. Non-Mira variable are a red giant ring much the same as the Sun, whose surface oscillates resulting in marked increase and decrease in brightness over periods between about 80 to 1000 days. Mira variable stage lasts for only a million years or so. Mira travels at a high speed, some 130 km per second, through space and creates a bow wave as it interacts with interstellar gas and dust. In conclusion, most common star in universe known as red dwarf. The M class covers the coolest hydrogen-burning star, but encompassing a wide range of masses, radii, luminosities, and expected lifetimes. Their mass below 40% and the mass of the Sun. The luminous is very dim and red color. These stars have a very long lifetime because they have burned their hydrogen slowly. Such a red giant phase can last up to a billion years, the least massive of such stars having the longest such phase.